To the equation number 1, in the same diagram, sketch the graph of y equals 3 times mod 2x and y equals 3 minus 2 mod x. This is, we'll define this first. 2x minus 1 modulus. Right, it changes at x equals half. Then 2x minus 1 modulus. On the right of half is 2x minus 1. Left of half here multiplied by minus sign, no? Minus 2x plus 1. Then the equations, when x less than half, I can take y 3 on the left of half. This takes this y equals minus 6x plus 3. When x greater than or equal to half, y will be equal to this. On the right of half going to be 2x minus 1. Y equals 6x minus 3. Right. Now we can put x half here. When you put x half here, y becomes 0. Here also when you put x half, y becomes 0. Right. Now we'll draw the graph. Right. So when you draw the graph, y-axis, x-axis. Okay, right. X equals half, y 0. Half 0 is, I will take somewhere here. Half 0 here. 1 point. And the intercept of this minus 3. Minus 3 is somewhere here. Then the graph should be drawn on the right of half. So we need to draw the line. We should have 2 points now. Then to take the 2 points, I take this and this. We join these two by dotted line. Right. So this part, of course, not coming into our graph. We use these 2 points to draw that line. We need only the line that after this point. So therefore, I produce this line this way. So therefore, this is the equation of y equals 6x minus 3, right? Okay. On this side, m point half 0 and intercept plus 3. The same 3 we have to take here. So we are here the point now then. Join this point and this point this way. Right? This is that line. This y equals minus 6x plus 3. Okay, we do that. Second line asked to draw is this 2 mod x. Here we can define mod x. Mod x changes at 0. On the right of 0, mod x is x. Left of 0, mod x is minus x. Correct, no? Right. Now, first thing here, x less than 0, we'll see what is this graph. Y equals 3 minus 2 times mod x on the left of 0 is minus. Y equals 3 plus 2x. Secondly, x greater than or equal to 0, y equals 3 minus 2 times on the right of 0, mod x is 6. 3 minus 2x, like this. Now, here, when you put x equals 0, we need 2 points to draw this line. No? Put x 0, y 3. Here also x 0 brings y 3. People 0, 3 point is this, no? Right. This is that point. Right. Another point we need here. Right. To take that point, we can, right, put another value there. Here, when x greater than or equal to 0, when I put here people y 0, when the y coordinate is 0 here, put 0 here, then bring this 2x this side plus 2x equals 3, then 2x equals 3 come in, x is 3 by 2, then other point is 3 by 2. So, to draw this line on the right hand side of 0, one point is this, other point is 3 by 2. x0, x3 by 2, y0, x3 by 2, y0. This point is 3 by 2. In that line, come in like this. This way. This is the equation you know. Y equals 3 minus 2x. Right. Now, this line, for that also the point is this. When I put y0 there, when we put y0 there, we get x as minus 3 by 2. The point to draw this line going to be y0, then x is minus 3 by 2. Okay. That means minus 3 by 2 point is somewhere here. Right. Okay. Minus 3 by 2 point is somewhere here. But join this and this. Right. So then this equation y equals 3. No. This is a graph. The two graphs we get. Okay. Now I'll take this point as A. Point A we can find its x coordinate is right by solving this equation and this equation. Okay. That two point capital A. Solve y minus 3x, y equals 3 minus 2x, and this and this intersect, no? Y equals 6x minus 3. Right. So, equate these y values means the right hand side we have to equate. 6x minus 3 will be equal to 3 minus 2x. Take this side, we get 8x. Take this side, we get 6. This gives us x by 4. This point is 3 by 4. Now, second part asking, so otherwise find real values of x satisfying mod 6x minus 1, then 1 minus 2 mod x. And so otherwise asking here, but people we use the diagram, the graph, right? Now I take this way. Now mod 6x minus 1 less than 1 minus 2 mod x. Right. Here I put for x here t by 3. For every x we put t by 3. Then what do you get? 6 into t by 3 minus 1. This way. Right. Now here we can cancel down. 2t minus 1. 1 minus 2 mod t divided by 3. Multiply by 3. 3 times mod 2t minus 1 is then 3 minus 2 mod t. This is what we get. That way we get. People now, this black graph, this equation is 3 times mod 2x minus 1. The red graph 3 minus 2 mod x. Now if I consider the range 3 minus 2 mod x, 3 minus 2 mod x is the red graph, I am going to find the interval of x. Red graph is above the black. That happens between this point and this point, that is in terms of x between 0 and 3 by 4. Then we can say, but by the diagram this happens, okay, between 0 and 3 by 4. This happens between x less than 3 by 4 greater than 0. People, now we can see this one, when we put x equals t by 3 and keep simplifying, we get this. The same thing here we have, only thing is for the place of t we have x. If for this the range of x is this, similarly for this we can write range of t as the same way. Therefore, you can write t less than 3 by 4 greater than 0. Okay? But what is your t? T is here. When you use the cross multiplication, t is 3x. Then put here 3x. This implies 3x is 3. Right. Now divide by 3. When you divide by 3, we get what, people? Here 0. X. Here 1 over 4. So therefore, for the given inequality, the range of x is going to be this. That's how we take the first answer. Right. First answer is this. Okay. Right, no? Okay, then we go to number 2. Question number 2, the limit question. Limit x going to minus 1. Right, number 2. It's going to minus 1 root 2 pi minus 2 cosinus x divided by square root of x plus 1. Root 2 pi square root 2 cosinus x divided by root x plus 1. Right. Then here we use a substitution. Let this cosinus x is, people, an angle, right? Theta equals cosinus x. When take cosinus x to this side, we get cos theta, x equals cos theta. Right. Now limit x going to minus 1. When I put here minus 1, cos theta equals minus 1. This occurs when theta equals 180. That means 5. That means x going to minus 1 means theta going to 5. Okay? Now I substitute for this. I write that first. Limit. Right. Write that here. Limit x going to -1 root 2 pi minus 2 cosine 6 divided by root x plus 1. X going to -1 mean here they're going to 5. Right. Root 2 pi minus 2 times cosine of 6 is theta. 2 theta. X is cos theta. 1 plus cos theta. We get this. Right. Now I multiply. Here this 2 I can take out. This cos theta I can write using half angles. 2 cos square theta by 2 minus 1. Then I can write here this root 2 pi I can write root 2 into root pi. That root 2 I take out. Root 2 a limit theta going to pi. Here root pi minus root theta divided by this cos theta I can write 2 cos squared theta by 2 minus 1. This and this we can cancel down. Then here we can take the root 2 cos squared theta root is cos theta by 2. So then this root 2 is done with this root 2. Then we get limit theta going to pi, right? Root pi minus root theta divided by cos theta by 2. This way I can write. Now I multiply numerator and denominator both by the conjugate of this. And meantime this one I write theta going to pi root pi minus root theta into its conjugate is root pi plus root theta, no? Then here also we must write root pi plus root theta is cos theta by 2 I write people sine pi by 2 minus theta by 2. This is sine 90 minus theta by 2 is cos theta by 2. We get, huh? Now this I can write a minus b into a plus b means a squared minus b squared pi minus theta, right? Limit theta going to pi minus theta divided by sine pi minus theta divided by 2 into 1 over root pi plus root theta this way. Okay, now this is what I do next. I can take this pi minus theta, the denominator of this. Okay, dividing this by 2 and multiplying by 2, we take that. That is our next line. And we take the limit. Okay, now limit theta going to pi, right? Here I divide this pi minus theta by 2. Meantime multiply by 2. Right, this way I am saying now. And this sine pi minus theta by 2. Right? 1 over root pi plus root theta. Now this part only I suppose take we are here. Right. Then 2. This one I can take out. 1 over sine phi minus theta by 2 divided by phi minus theta by 2. Right. And here also we put the limit. Theta going to phi. 1 over root phi root theta like this. Huh? Now you can see here theta going to phi means this phi minus theta difference going to 0. That divided by 2 also going to 0. Then here you have sine theta by theta. Theta going to 0 form. This is now 1. Right? It is 1. This part is 1. Here theta going to pi means this will be pi. Here we have 2. 2 into 1 over root pi plus root pi. 2 over 2 times root pi. This 2 you can cancel down. We get 1 over root pi as the answer. Correct, no? Next one, question number 3. Right, number 3. Question number 3. The parametric coordinates of a point on the hyperbola this are given to sec theta, theta and theta. So that the equation of the perpendicular drawn to this hyperbola at the point 2 sec theta, 3 tan theta is given by this equation. Right, no? Number 3. The equation x squared over 4 minus y squared over 9 is x given by 2 sec theta, y given by. Okay. Right. Parametric coordinates. Right. X coordinate of any point on the hyperbola given by 2 sec theta, y 3 tan theta. Now asking to find the equation of the perpendicular at the theta 3 tan theta. Yeah, first I am going to differentiate this to find dy by dx. X squared over 4 minus y squared over 9 equals 1. No? Here 4 we have to keep as same. X squared derivative is 2x. 9 here same. 2y dy by dx. Right hand side 0. 2 you can cancel down. Then you can subject here dy by dx. Take this right hand side and 9x by 4y. No? Is the dy by dx. Right. Now we need to find the dy by dx at point. Then the coordinates of x and y should be substituted for here and here to find the dy by dx at that point. 9 by 4. X coordinate is 2 sec theta. Y coordinate is 3 tan theta. This and this we can cancel down. This and this we can cancel down. Sec theta means 1 over cos theta. Tan theta means sin theta over cos theta. That cos theta, this cos theta we can cancel down. We get sin theta here, no? Then we get 3 over 2 sin theta as our dy by dx. Therefore, dy by dx come in as 3 over 2 sin theta. Right. Now dy by dx gives us what, people? Gradient of the tangent. Gradient of the tangent. We need the gradient of the perpendicular to find its equation. Gradient of the perpendicular can be obtained taking the reciprocal of the gradient of the tangent and multiplying by minus sign at the same point. So therefore, gradient of the perpendicular. What? The reciprocal of this minus 2 sine theta by 3. Now we need to find the equation of the perpendicular. To find that, we can use this one. Y minus y naught equals gradient times x minus x naught. This gradient only here we found. And x naught, y naught going to be the x and y coordinates at the point to which we draw the perpendicular. That means x2 sec theta 3 tan. So therefore, y naught 3 tan theta, x naught 2 sec theta. Then we get y minus 3 tan theta, gradient is minus 2 sin theta over 3, x minus 2 sec theta. Right. When you simplify this, we get this answer. Multiply this by 3, then we get 3y minus 9 tan theta minus 2 sin theta times x, right? Minus minus plus 2 sin theta, 2 and 2 make 4, no? Right. Minus minus plus 2 and 2 make 4. Sin theta sec theta means tan theta. Correct, no? Sin theta over cos theta, no? Alright, so then when you simplify this, take this side, we get 3y plus 2 sin theta times x. Once you take this side, we get minus 13 tan theta equals 0. Is the equation of the perpendicular. Now what is asking next? Next part is also find the equation of the perpendicular drawn to the hyperbola at the point 4, 3 root 3. Right. Right. Any point on the hyperbola using parametric coordinates, x coordinate we can write as 2 sec theta, y coordinate is 3 tan theta. Now we are given the point as 4 and 3 root 3. Right. So by comparing this x coordinate or this y coordinate with these two, you can find theta. Okay. To get this point, the corresponding theta can be found. The theta figure you can put where here, then we get the equation of the perpendicular at the point 4, 3 root 3, right? Alright, so then if I do so, what happens is, people, I am going to equate this and this. 3 tan theta equals 3 root 3, this and this we can cancel down. Then tan theta root 3, theta pi by 3. The theta pi by 3 will substitute where here. Then we get the equation of the what? Perpendicular at the point. Now required equation of the perpendicular. 3y plus 2 sin pi by 3x minus 13 tan pi by 3 equals 0. 3y plus sin 60 root 3 by 2. This and this we can cancel down. Then we get root 3x. Tan pi by 3 is tan 60 root 3. 13 root 3 equals 0. This way you can take that equation. Right. Right, number, we finish this way. Number 4 next. Fourth one. Question number 4 says the line simple L with gradient 3 passes through the point A to 1. Right. Okay, and then B is a point on the line L such that AB equals 3 root 10. Find the possible coordinates of 4B. If these points are B1 and B2, find the area of the triangle B1 or B2, where O is the origin, right? Okay, the given thing is this. Line L is this. Its gradient is 3. Point A is 2, 1. It is on the line. B here. X bar, Y bar. Right. The length between A and B going to be 3 root 10. Right? 3 root 10. Now asking to find the coordinates of the point B. There are 2 locations for the point B. One is as in the diagram above the level of A, other one on the same line L below the level of A. The 2 points coming like that. Huh? Okay. Now let's see. I'm going to first write the gradient of this line L using x bar, y bar and this 2, 1. Then it is difference of y coordinates y bar minus 1 divided by x bar minus 2. That is equal to the gradient of the line L given as 3. Then I write it like this, bring this 3 way here, x bar minus 2 way here, divided by 1. Next step here, I write introducing a parameter t here. Then I can equate this to t, x bar minus 2 equals t, y bar minus 1, use the cross multiplication, 3t. Right, so then we can subject x bar by this, t plus 2, y bar, 3t plus 1. This way, x bar, y bar you can subject. Now we know the distance between A and B, 3 root 10, then AB squared is 90. After squaring the right hand side. Huh? Now I can write AB squared, difference of x coordinates per x squared plus difference of y coordinates per x squared equals 90. X bar minus 2, it is t. Then this is t squared. Y bar minus 1, 3t. Then 90 squared is equal to 90. Then here we get 10t squared equals 90. Then t squared equals 9. T equals plus 2 minus 3. We get 2 answers for this parameter t because there are 2 locations for the point B subject to the given conditions. Okay, right. Now I can put t equals 3. When t equals 3. When t equals 3, when you put here, we get 3 plus 2, it's 5. Here, 10. Then 1.4 is 510. Secondly, when t equals minus 3, we get 1 point is minus 1. Minus 3 when we put minus 8. This way, the 2 locations for the point B we get. Huh? Right. Now ask in turn. Yes, find the area of the triangle B1 or B2 where O is the origin. Then it's a very, very simple thing. I simply draw the diagram like this. Here O 0 0 point. I take B1 as the 5 pin. B2 minus 1 minus 8. Right. Now we'll use OB1 B2 triangle area equals half modulus. Right. Now you know we rotate this way. Right. Keep this 0 before, and difference of the y coordinates of the other two points 10 minus minus 8 plus 8. Then come to here, keep this 5 minus 8 minus 0 minus 8. Alright, and keep this minus 1 there. Then minus 8 minus 0, no? Right, no? Right, so then first we kept this 0, 10 minus minus 8, this is correct. Come to 5 here, keep 5 here, minus 8, 0, and then minus 1, 0 minus 10. Right, you know, this is now 0, half, here minus 40, here plus 10. Then here we get minus 30 modulus, then 15 square units come in. 15 square units come in as the answer. Right now. Question number 5. Next one. X plus cos x plus root 3 sin x in the form r cos x minus alpha, where r positive and alpha between 0 and 90. Hence solve the equation this. Right? Let's see how to take that. Okay, cos x plus root 3 sin x. Right. Now 5. Cos x plus root 3 sin x. Right, here we take this cos x coefficient 1, sin x coefficient root 3, no? We square them and add, and we take the root. Here we get 2. By this 2, we multiply this expression and meantime divide by the same 2. This way. We divided this and this both by 2 and meantime multiply by 2. Expression 1 change. Alright, now I can write this one. I can write cos 5 by 3 plus sin x into sin 5 by 3. In this takes the form cos A cos B plus sin A sin B. That is cos A minus B, no? 2 cos x minus 5 by 3. Then we wrote. So then asking to write it in the form r cos x minus alpha, no? Comparing with r cos x minus alpha, we can write r to alpha 5 by 3. Correct, no? Hence solve the equation this r. Hence solve the equation cos x plus root 3 sin x right is equal to 2 cos x plus pi by 4. For this now, you can put this 2 cos x minus pi by 3 equals 2 cos x plus pi by 4. This and this you can cancel down. Now we have cos equality. Now you know how to write the general solution cos equality. This angle x minus pi by 3 is equal to 2 in pi plus or minus x plus pi by 4. Here n is integer, right? But we have subject x, no? Then we first take plus sign. Right hand side we get plus x. When I take this left hand side, we get minus x. X minus x, we won't get x. Then by plus sign, we won't get one answer. So only the minus sign. X minus pi by 3, 2 in pi, remove the bracket by multiply minus sign, minus 6 minus pi by 4. So once I take this side, we get 2x, 2 in pi, minus pi by 4, take this right hand side, 3, and divide by x, divide by 2, in pi minus pi by 8 plus pi by 6. N is any integer. Right? N is any integer. Right? This is how we take that. Right. Next one, question number 6. Impact of elastic bodies. Question number 6. Right, number 6 is two particles P and Q of masses 2m and 3m moving with velocities 3u and 2u towards each other on a smooth horizontal plane collide directly. After the collision, the particles move away from each other and the velocity of Q is u. So that the coefficient of resolution for the collision is half and the loss of kinetic energy of the particle P due to collision is this much. Yeah, we'll come to that. Here, P mass 2m, Q mass 3m, this moves this direction with velocity 3u, this with velocity 2u. After the impact, we are given q moves, right, in the direction. After the collision, the particles move away from each other, right. So Q should be then move to rightward, P leftward. This is how we have to take. Right. And I'll take this velocity as W. This is given as U. Velocity of Q after the collision given U. Right. Asking to write Newton's law of distribution. Alright. So now we apply Newton's law of distribution this direction. It says minus c times relative velocity before impact will stop this Q. Same to you onto this. Then this will be at rest. This will get to the right 3u and 2u, then 5u. After the impact, again I stop this Q. For that I have to apply u leftward. Same u I have to apply on this p leftward. Then we get u plus w. Then in the right, that u plus w should be negative. Minus you can cancel down. First equation you can write 5eu right hand side. Number 1. Now we apply secondly conservation of linear momentum rightward. Just before impact, total momentum is equal to the total momentum just after impact in the rightward direction. Right. So here 2m and 3u we have to multiply 6mu, but this will have leftward, therefore minus 6mu. mu minus 2mw. This is 0. 3mu minus 2mw. M and m you can cancel down. You can write w equals 3u by 2. That we can put where here. Then we get this e. Now by 1. Now by number 1. U plus w. u by 2 equals 5eu. U you can cancel down. Here 3 by 2 means 1.5. Here 1, 2.5. That means 5 by 2. Here 5e. This and this you can cancel down. E equals half. We get E half like this. Now next one asking loss of kinetic energy of the particle P due to collision. Loss of kinetic energy. Right. W we know it is the velocity of P after impact. Loss of kinetic energy how to find? Initial kinetic energy minus final kinetic energy. Loss of kinetic energy of P. Loss of KE of P. Initially it was moving with velocity 3u, no? Half mass 2m 3u squared. After the collision it moves w velocity 2 by 2. Then there we get half 2m 3u by 2. Then I can take half 2m 3u perfect squared. Then here we get 1 half 2m 3u perfect squared. When you take here we get 104. Right. Now we'll simplify this. This and this we can cancel down. 9m u squared. Here 3 by 4. We get 27 mu squared over 4 is the loss of kinetic energy. Understood? Right. I will go to question number 7 next. Question number 7. Take question number 7. Yes, a small plug line at the lowest point inside fixed smooth hemisphere with its rim horizontal jumps with its maximum velocity to a point on the rim. If the two possible angles it can aim are alpha and beta, show that tan alpha plus beta equals -1. Projectile question. Right. Okay. So, question one is this. Right. Here. Ball. Right. Like center here. This is the place where the frog lies. Right. This way. Frog jumps over. Right. Suppose with velocity u it jumps with an angle theta. This way it comes. Right. Okay. Now the radius of the ball will take as simple A. Yes. Then this is A. This is A. Therefore, this is A. This is here 90. Right. Now, if I take this as point O as A, for OA motion, now you can apply S equals UT rightward. S is therefore A. U is U cos theta times T. T equals A over U cos theta. Right. Oh, we apply circle A. S equals UT plus half AT squared vertically upwards. Right? Then there we can find another equation. S is this A, U sin theta times T minus half GT squared coming. Correct, no? Right. Now we can substitute for this T and this T from this answer. A equals U sin theta. T means A over U cos theta minus half G. T squared means A squared over U squared cos squared theta. This and this you can cancel down. And 1A you can cancel down here. Here we get 1. Then we get tan theta here minus GA divided by 2U squared. 1 over cos squared theta is sec squared theta. Sec squared theta is 1 plus tan squared theta. Now, multiplying this by 2U squared, we'll take all the terms to left hand side. Okay, then we get GA tan squared theta. Here minus 2U squared tan theta. Then this is now 2U squared plus GA equals 0. This is the quadratic equation we get. This is the quadratic equation we get in triple tan theta. Okay, right. Then we can now write, since this is the quadratic equation in tan theta should have two answers. That theta is the angle which makes with the horizontal the frog initially jumps from the bottom of the hemisphere. Then that angle theta in the diagram given by this. This is a quadratic equation, therefore theta should have two answers. I am going to assume that two answers has alpha beta. In the question also given, if the two possible angles, it can aim alpha beta. Therefore, that two answers for theta should be alpha and beta. Then the roots of this equation should be tan alpha and tan beta. Since this is a quadratic equation, you know for a quadratic equation, the sum of the two roots and the product of the two roots we can write. Using that theory, I write tan alpha plus tan beta and tan alpha tan beta product. Okay? Then tan alpha plus tan beta. Sum of the roots going to be minus tan theta coefficient divided by tan square theta 2u squared over what? Ga. And product of the roots tan alpha into tan beta is equal to the constant term divided by tan square theta coefficient. 2u squared plus Ga divided by Ga. Asking people tan alpha plus beta answer. Tan alpha plus beta answer only asking. Tan alpha plus beta answer. So to find that, what we do is we write tan alpha plus beta formula. Right? Tan alpha plus beta formula is what? Tan alpha plus tan beta. Tan beta 1 minus tan, right. In left hand side we have tan alpha plus beta equals tan alpha plus tan beta is this 2u squared over Ga divided by 1 minus this 2u squared plus Ga divided by Ga. Alright, now we can write this, simplifying further. Okay, right, we can write yes, 2u squared over Ga. Here also Ga, when you take common denominator, this is Ga minus 2u squared minus Ga. Right, okay. Then we can cancel down this and this. Then here we get 2u squared over Ga numerator. Here we get minus 2u squared over Ga, same thing. Then cancelling down this 2, again we get to the right hand side and answer minus 1. Then we get the answer tan alpha plus beta equals to minus this way. We can take that answer. Right. Next question is number 8. Cooperative process question. Uniform rod AB of length 3r is placed in a smooth fixed hemisphere of radius r, whose rim is horizontal, such that the end A is in the ball and the end B projects beyond the rim. The rod lies in the vertical plane through the center of the ball, and if the angle the rod makes with the horizontal is alpha, show that this answer. Show that this answer. Right. We'll come to that. Right. So the center of the ball. Right. Produce place like this. Then here the reaction coming to the rod by the ball is perpendicular rod. Here the reaction coming to the end of the rod will pass through the center of the right. So then if I mark them, I can mark them like this. This is one reaction. And here right. Suppose reaction is yeah. Right. Now there is in equilibrium under the action of three forces, no? So the third force is weight of the rod. We know, we have learned, whenever any object is in equilibrium under the action of three forces, the three forces must meet in a point, or they must be parallel to each other. But in this case, the parallel story not valid because already two forces meet at a point. So therefore, the line of action of the weight of the rod produced should pass through that point where there is two forces meet here. Then I will mark that like this. First I draw vertical line through the point this, right? No, then this point should be the center of gravity. Right. Weight acts through the point this. Right. Now here A, this point is B, here 9, right? We are given there rod AB of length 3R, uniform rod, center of gravity is at the point. Length of the rod is 3R, mean from here to here 3R by 2. The length half of the whole length, right? 3R by 2. Okay. Radius of the ball is R. Right. Radius is R. So then radius I can mark like this here. Therefore, from here to here the radius R. From here to here the radius R. Okay. And we are given the rod lies in the vertical plane through the center of the ball, and if the angle the rod makes with is alpha, right? Few people here draw horizontal line to the point A. Definitely that line passes through the point this. We draw the diagram correct. The horizontal line through the point capital A meet the ball at this point, and this angle is going to be 90. The reason, this is diameter. This is a diameter. I drew here horizontal line. This W is vertical line. This horizontal line and this vertical line meet at 90 angle. Right. So the same story now we can see. This is the diameter. The two ends of a diameter of a circle meet at the point at right angles. Such point should be definitely on the circumference. Such theorem in circles, in oils, you have learned. Okay, therefore they must meet here. Now this angle only alpha. This also people horizontal line. So then by alternate angles, this is alpha. This side, this side and this side equal. Therefore, this angle and this angle should also be equal. This is also alpha. Now people to take this arms in this case, we can use a geometric method. The radius is r, no? Then this also r. Here to here, the whole length is 2r. This is 2 alpha. Then this length you can write as 2r. This is 2 alpha means 2r cos 2 alpha. The same length, this you can write using this 3r by 2 and this alpha. Same length I can write 3r by 2, this length cos alpha. Right? Then these two lengths we can simply equate. Then we get the answer. Geometric method, right? Yeah. Then by the diagram, right, we get 2r cos 2 alpha is equal to r and r down. We will divide both sides by sin 2 alpha. Then we get 2 cos 2 alpha divided by sin 2 alpha 3 by 2 cos alpha. This sin 2 alpha here I write 2 sin alpha cos alpha. Then this and this cancel. Now I can take here this 2 here and we get this is cot 2 alpha. No? Once I take this 2 here, we get 8 here. 3 by 8 sin alpha. What is asking? Yeah. This cot 2 alpha I can write as 1 over tan 2 alpha. 3 over 8 sin alpha. Then you can subject tan 2 alpha. Bring this here and this here. Tan 2 alpha is equal to 8 sin alpha over 3. This is how we take that answer. Correct, no? Right. Question number 9. Related to acceleration question, right? Right. And inelastic string whose end joined to a fixed point A passes below a movable pulley B of mass 2m over a fixed pulley C and below another movable pulley D of mass 2m. Has its other end joined to the center of the pulley B as shown in the diagram. The system is released from rest. Find the tension in the string. Right. Very simple question. Right. We'll do the diagram there. Yeah. the diagram, right? This is the C, this is the D, this is B. The mass of this is 2m, weight is 2mg. Tension acts downward, here upwards. Here also mass 2m, weight 2mg. Tension upwards, here P downward. Here this is the same tension along the string everywhere, because the light and inextensible string given us. Okay, the diagram is correct. Now, at time t equals t only, people, we have drawn this diagram. That means initially we release the system to move, and we allow it to move during a time interval t, and that instant the diagram only we have drawn. Yeah, now I am going to measure, right, the distances for this D and B from the fixed level. As my fixed level, I take this level. I take to this the distance as x at time t equals t. Then the acceleration you can mark there, x double dot. You know the method there. To the direction of this, measuring the length. The length we have measured downward direction. Arrow points downward of the length measuring here. Then it should also be marked to that same direction. Then acceleration x double dot downward. We will take to this length, to this level, the length from this level as y. Right. Then there the acceleration y double dot. Now at time t equals t, I can write the total length of the string. What, people? This is y, this is y, this is x, and from here to here, the length going to be, all thing is y, this thing is x, then this length going to be x minus y. And this part of the string is constant, this part also constant, this part also constant, right? And this part constant. There are some constants to be added. Once we add some constants, the answer is another constant. All those constants I take as one constant as c, right? And then we first write what? For the length of the string, the first equation we write. For the length of the string, right? Here y, then 2y, here x, and from here to here, all in x, this is y, then x minus y. And that should be equal to L. What is L? Length of the string. Length of the string. Right. Now we can this. Here we get x 2x, 2y minus y is plus y, plus c is equal to L. We differentiate twice. Differentiating twice with respect to, we get here 2x double dot plus y double dot. This is a constant 0, 0. This is the first equation relating the accelerations of this B and D. Now we can apply, people, F equals ma for this D and B, right? Now applying F equals ma, number 1 for B, downward. What are the forces acting downward? 2mg plus t downward. Upwards, t and t 2t. We get 2mg plus t minus 2t equals 2m is the mass. Expression is y double dot. 2mg minus t equals 2m y double dot. I divide this by 2m and we get g minus t over 2m equals y double dot. Okay. Take this as number 2. Now we apply FMA for this D. Secondly, for D. We apply down. What do you get there? 2mg minus 2t equals here 2mg minus 2t equals 2m x double dot. Here also we divide this by 2m g minus, right, 2m when we divide g we get minus t over m. Correct. Now when we divide by 2m, t over m come in x double dot. This is number 3. People asking to find what? The tension T. The best way in this case to find the tension T is by this 3 and this 2, the y double dot x double dot, we substitute in number 1. Then we get the T very easily. Right? Substitute in number 1. Okay. We get what? 2 x double dot. This minus t plus y double dot. G minus t over 2m equals 0. Right. Now here 2g and this g, 3g no, take to right hand side, minus 3g. Here minus 2t over m minus t over 2m. We'll take minus and t over m out. Then minus t over m when you take out, here we get 2. Right. Minus t over m when you take, here we get plus half. Right. So minus signs we can cancel down. T upon m. 2.5 when we add 5 by 2. Here 3g. Then this gives us, right, 2 and 3, 6 mg by 5 as the tension T in the string. Correct. Right. This is the question number 9. Let's take question number 10. Last question in the paper. Okay, question number 10 says a motor car of mass capital M moves with maximum velocity u on horizontal path when its engine works at the power h kilowatt. When the engine works at the same power, the maximum velocity up along a path of inclination theta to the horizontal is v. If the resistance to the motion remains unchanged, show that h equals this. Okay, right. Work and power question. Right. Now, motor car of mass capital M, right, moves with velocity u on a horizontal path when its engine works at the power h kilowatt. Right. Number 10. Right. This is the motor car. Right. Works at the power h kilowatt. H kilowatt power means people in terms of watt, h into 10 to power 3 watts. Standard unit is but no, right. Then in this case, it moves with velocity u. We know h equals Fv. H is the power. F is the tractive force. V is the velocity. If we assume the tractive force in this case as F, we can subject this F. H is 1000 H, no? Over there. Velocity is U. The resistance acts this way R. Right? Mass given as M, no? Right. Now, ask in this way. But in this case, the motor car moves on the horizontal path with maximum velocity. You know, when the car moves with the maximum velocity, the tractive force is equal to total resistance. Therefore, F should be equal to R. F equals R. So, therefore, this R is equal to the tractive force 1000 H over U. 1000 H over U is the resistance. When the engine works at the same power, the maximum velocity up along a path of inclination theta horizontally is VR. Right? Now the car moves with power up a hill whose inclination to the horizontal is theta. This way. Right. Then the car moves this way. The maximum velocity given as people V. The same power. Then in addition to the resistance earlier, that weight mg of the car, mg weight vertical acting, vertical downward, no. Its component downward on the plane going to be mg sin theta. That's also now acts against the motion of the car. Right. Now the tractive force I mark as F dash. Alright. Now this time this F dash becomes 1000 H power divided by the velocity. Right? Now you know when the car moves with constant velocity, no resultant force. When the car moves with constant velocity means no acceleration, no. For no acceleration, there should not be any resultant force. It means up along the plane, up along the hill, the total force should be equal to down along the same plane, the total force. That means this F dash should be equal to R plus mg sin theta. Therefore, F dash should be equal to R plus mg sin theta. F dash is 1000 H upon V, R here 1000 H upon U plus mg sin theta. Okay. Then people, you can subject H by this answer asking H. Take this side, take 1000 H out. Then here we have 1 over V minus 1 over U. Here mg sin theta. Now we can subject H. How? 1000 H within bracket take the common denominator as UV product. Then this U comes here, V comes here. U minus V is equal to mg sin theta. Then use the cross multiplication this way. Subject H. H going to be mg UV sin theta. Bring this sin 1000 denominator. 1000 U minus V. So this way we get that answer. That comes in terms of what? Correct, no? In watts only it comes. Right. So this is the end of the